Okay, so in this problem, we're going to work on do some circular motion problems. So there's a couple things you need for this problem. The first thing is you need to make sure you have your formula sheet because it's got some, some formulas that you need to know. And then the other thing that you need is, it's still your formula sheet. You need you're going to need the value for big G, which is your gravitation. So make sure you have your formula sheet because it's got the formulas you need for this and the constant. So let's go ahead and see what we've got. We have a 95 kilogram astronaut. He's in orbit 4.25 times 10 to the 5 meters above the Earth's surface. And then they give you the mass of the Earth and the radius of the Earth. And then they say, what is the radius of the orbit? So in order to do the radius of the orbit, you need to add the radius of Earth. Because if you remember with our problems, with these gravitation problems, our diameter is calculated from the center. So we need the radius of the Earth right here. And then we need the radius of our orbit. Okay? So we have our radius of our Earth. And then we have the radius of I guess, like the height. I'll call it the height. That way we don't get confused. So let's call that the height. We'll call that the height. Okay. So we're going to do this 6.378 times 10 to the 6 meters plus 4.25 times 10 to the 5 meters. And that's just going to give us 6.8 times 10 to the 6 meters. Now, for part B, we are going to use this same, we're going to use our answer from part A, so just kind of keep that in mind. For part B, they're asking what is the weight of the astronaut. So, usually our weight is Fg equals mg, but because this astronaut is in orbit above this very large object, our gravity is actually going to be, it's going to be this formula. Okay, and that big G, that's that constant I was telling you that you would need on your formula sheet. And then you can multiply the mass of the astronaut and the mass of Earth. Okay, and I like to put these brackets around it just because I want to remind myself that I need to do that first. And then for our radius, we're not going to use the radius of Earth. We're going to use this total radius we got in part A because the astronaut isn't standing on Earth. He's, above Earth this amount. Okay. And so let me see what I got. 3.78 times 10 to the 16th. So I multiplied these three things together first. And I took this, I squared 6.8. And then I went from there. This should be a 16. Sorry about that. And so my answer was 818.41 newtons. Okay. So that's how you'll solve that type of problem.